our third and final video on substitution. Today we're going to focus on negatives and fractions, which I know are our two favorite things about math. So in this video we'll work with negatives several times because we need the practice. We'll discuss how to kill fractions, which is a very satisfying feeling. And we'll do a word problem because we love word problems so much I have to keep working on those. So I'm just going to solve this down here by substitution. And notice how many negatives I have all over these two problems. We cannot let negatives cause us to make mistakes or errors. Think about this, okay? It is almost the smallest symbol in mathematics, right? Like division is definitely bigger. Plus is definitely bigger. The decimal point is the smallest. Or, you know, if we think of that as like times, that is the smallest. But negative is probably the second smallest symbol we have in mathematics. Things that are small are important, right? Like the smallest words in our language are the most important words. Words like and, it, of, the, for, if. They're very small and important because we want the important words to be easy. We don't want to be saying like long, frustrating words several times per sentence. That's why kids say mom and not mommy or mother or mama when they're first starting. They just say ma. So negative is a very important symbol, and it's a small one. We have to be on top of the smallness. If you want to take this negative right here and make it a negative 1, you can. If you want to take this negative, make it negative 1 and negative 1 and make that a positive 1, you can. But you should get better than that. You should be able to just see that and think, oh, it's like there's a 1 there. I'm going to have to deal with that negative 1. I'm going to isolate this y. Why? You get it? Why? Why? Because it has a coefficient of negative 1. And having a coefficient of negative 1 is the easiest one for me to solve for. So let's get this y by itself. I have the equation 2x minus y equals 15. I start by subtracting 2x from both sides, which gives me negative y equals negative 2x plus 15. You don't have to put that negative 2x in front, but I think it is more familiar if you do. But do not lose sight of this negative. Now, we don't care what negative 1 is, or we don't care what negative y is, I should say. We care what y is. So I'm going to multiply both sides by negative 1. If you want to, you can also think of it as dividing both sides by negative 1. It doesn't matter to me because that's the same thing. You could also just change the sign of everything. We get y equals 2x minus 15. Okay, I have now solved for y. I take that y and I plug it into the other equation's y. Okay, so that becomes 3x minus 2 times 2x minus 15, and that all equals 23. I'm going to distribute the negative 2, not positive 2, but negative 2. Distribute negative 2 to both of these two things to now solve this equation. So it becomes 3x minus 4x plus 30. Okay, negative 2 times negative 15 is positive 30, and that equals 23. Combine my like terms. 3x minus 4x is negative x. Here's yet another negative for us to live with. Negative x plus 30 equals 23. Subtract 30 from both sides, and we get negative x equals negative 7, which means that x equals positive 7. I don't care what negative x equals. Negative x equaling negative 7 is of no use to me. I want to know what x equals. X equals positive 7. Again, you can just switch the signs or multiply both sides by negative 1 or divide both sides by negative 1. All those things are the same. Now that I know what x is, I'm going to take it and plug it into this equation up right here. So y equals 2 times 7 minus 15. So y equals 14 minus 15. So y equals negative 1. My solution is the point 7, negative 1. I'm going to check that, and I'm going to check that in this equation, because that is not the one that I used to find y. I technically used this equation right here to find y, because that's how I got this over here. So I'm going to check it in this one. If I do 3 times 7 minus 2 times negative 1, that should come out to 23, and 21 plus 2, because negative 2 times negative 1 is positive 2, 21 plus 2 does equal 23, so it checks. Beautiful. Okay, now, I might have gone through that a bit fast for you. This is our third day of doing this, and I want to remind you that you can always pause, you can always rewind, you can probably watch this at like 0.5 or 0.75 speed if my speed is too fast. But what's, I think, the most ideal position for you to be in is to try to be just a little bit ahead of me, okay? So I'm going to be doing this problem. If you're going to just follow along without doing the work on iPad or paper, okay, try to know what I'm going to do before I do it. That should be a goal you have pretty much always. See if you can figure out what the move's going to be before the move actually happens. So right now you should be saying to yourself, okay, he's either going to solve for this x, or for this y. Now, honestly, the variable that I should solve for is this y right here, because it's going to be the easiest one to get by itself. I think I was planning on picking a different variable just to show how to fight with the negatives. So I am. I'm going to pick a different variable. I'm going to solve for this x right here just to show you what happens if there's negatives to play with. Like, I should have made this a 2y. That's what I should have done. In fact, let's just pretend like that is a 2y, all right? Let's pretend like this is actually an equation with a 3y right here. I actually know, because I wrote this problem, I know it's not going to change the answer, which is kind of cool. It's a special problem that way. So let's solve for this x right here. To solve for that x, I add 6y to both sides. And that becomes negative x equals 6y plus 10. I don't care what negative x is, I care what positive x is, so x equals negative 6y minus 10, because I divided or multiplied both sides by negative 1. I now take this and plug it into here, this x right here, and I have 3y minus negative 6y minus 10. All of this plugged in for this x right here. And that equals 10. Now something kind of funny is going to happen with this problem, and I did this on purpose. When I distribute this negative, I'm going to get 3y plus 6y plus 10 equals 10. Distributing a negative all by itself is something else we just can't lose sight of. We're subtracting the whole quantity, negative 6y minus 10, so we can't lose sight of the fact that it has a negative that has to get distributed. When I solve this, I'll combine these like terms. 9y plus 10 equals 10. Next, I'll subtract a 10 from both sides, and that gives me that 9y equals 0. This might feel weird. This might feel odd. You might think that this is a no solutions or infinite solutions case, but it's not, because it still has a variable with it. If there's still a variable, we keep solving. I'm going to divide both sides by 9, and we get that y equals 0, because 0 divided by 9 is 0. If I take that y equals 0 and plug it back into this equation up here, I'm going to get that x equals negative 6 times 0 minus 10, which means that x equals negative 10. My solution is the point negative 10, 0. It's okay to have 0 as a solution. In fact, I think it's kind of preferable because it makes the calculations really easy, right? Multiplying by 0, pretty simple. And so we check, if we plug in negative 10 for x, this becomes negative 10, and negative 10 is just 10. And 10 minus 6y, if y is 0, is just 10 minus 0, which is 10, which checks. Same thing here. We plug in negative 10, that becomes a 10. We plug in a 0, that becomes a 0. 0 plus 10, or sorry, 0 minus 10 is negative 10, which checks. This is a plus, sorry, plus 10. Cool. Do I want to do one more example of this? Here's the deal. I'm going to do this example, and if you feel like you are good with this topic and want to skip it, I'm okay with that. If you need more practice, take the more practice. And don't just do the thing that is easier. Do what you need, okay? Identify, what do I need as a student to succeed and to understand? It might be you don't need to see one more example, but my guess is you probably do. Okay, I'm going to solve for this y because it is the smallest, and if I divide everything by 3, eventually I'll have whole numbers, and I like having whole numbers. Since I know that one works, I'm going to solve for this y right here. My first step is to subtract 6x from both sides. That gives me negative 3y equals negative 6x plus 12. Next, I'm going to divide everything by negative 3. I have to divide everything by negative 3. Everything is divided by negative 3. So that becomes 2x minus 4. Take that 2x minus 4. Now I know that y is equal to. Take that 2x minus 4 and plug it into the other equation. And this becomes negative 12x plus 6 times 2x minus 4. And that equals negative 24. Do some distributing. 6 times 2x is 12x. 6 times negative 4 is negative 24. These 12x's cancel. They're gone entirely. That's just 0. It's not 0x. I mean, I guess it is 0x, but 0x is just 0. So we don't write 0x very often because that's just 0. We get negative 24 equals negative 24. That's a true statement with no variables. This has infinite solutions. Okay? Infinite solutions, handle your negatives. That's what we're talking about here. All right, now let's kill some fractions. Take out all your anger and frustration you've ever had with fractions by killing them. You can only do that when you have equations that involve them. But we're going to do some substitution here. Watch what happens. I know that y equals 5/4 x. So I'm going to take that and plug it into the other y equation. That means that on the left side I have 5/4 x, and on the right side I have 5/2 x plus 3. Note that these two equations right now are in slope-intercept form. So this is a very common type of equation to actually see. We could solve this by graphing, but it might not graph that well, like they might not cross at clean points. So we need to know how to solve these by other methods. So we're going to be able to solve with fractions by killing off the fractions. So I took this, plugged it in here, and that gave me this. Now, I want to kill the fractions. The question is, what is the lowest common denominator? Well, think of this as the fraction 3/1. Okay, every number is actually a fraction, so take every non-fraction and make it a fraction right now. 1, 2, and 4 all go into the number 4. So the lowest common denominator, which we call an LCD, is the number 4. I need to make every single number have the denominator of 4. So the way that I do that is I recognize the left side doesn't actually need anything. This fraction I'll multiply by 2/2. This fraction I'll multiply by 4/4. And now I get 5/4x equals 10/4 plus 12/4. Here's the beauty of this. Now that I have a common denominator, the murdering happens. I multiply both sides by 4, and all these 4's cancel. That gives me 5x equals 10x plus 12. Okay, I killed my fractions before I started my solving. Now the fractions are gone. I'm not going to worry about lowest common denominators. I'm not going to worry about flipping and multiplying. I just start solving. I'm going to subtract 10x from both sides to get away from that 12. And that gives me negative 5x equals 12. What? This feels off somehow. Nope, I think it's okay. I thought this was going to work out to a nice, clean, pretty number. But it's not, and I can live with that. X equals 12/-5. That's one of my solutions. Now I've got to find y. You might think that finding y is going to be a huge pain. However, if I just plug this into this equation right here, I get y equals 5/4 times 12 divided by -5, and the 5's cancel, which is so awesome. So that becomes 12 divided by -4, which is -3. So the answer is 12 over negative 5, which I'm just going to call negative 2.2. It's 2.4 actually. Let's just make that negative 2 and 2 fifths. Negative 2 and 2 fifths, comma, negative 3 is my solution. Sweet. Okay, there's one example. Watch it a few times if you need. We'll go over it in class if we get to meet in class. Here's a word problem for us. You have $200 and earn $100 every 2 weeks. The cost of a limited edition copy of the new PlayStation is $500 and increases by $20 every 3 weeks. When can you afford the console? Let's talk about your money. Let's talk about the console cost. Okay, I'm going to set up the variable x to stand for time, and that's going to be in weeks, and the variable y to stand for money, and that's in dollars. And here's what I know. For me, my total money y is equal to, I'm getting $100 every 2 weeks, and I started with $200. That is my equation. I'm going to simplify that so it looks prettier. Y equals 50x plus 200. Here's my slope, $50 every week. Here's my starting point, $200. For the console, its cost is $500 as its starting point, and it's going up by $20 every 3 weeks. So my equations are y equals 50x plus 200, and y equals 20 over 3x plus 500. These are my two equations. I want to substitute and solve. Well, don't want to use that. I'm going to take this and plug it in here. So I have 20 over 3x plus 500 equals 50x plus 200. Now, we can still kill the fractions even though there's just one fraction. Because remember, technically there's 3. What I'm going to do is just multiply every single thing by 3. And that gets me 20x plus 1500 equals 150x plus 600. Okay, because this 3 canceled with this 3, but then everything else had to get multiplied by 3 when I distributed. So everything got tripled, including 20 thirds. 20 thirds getting tripled is just 20. Do some solving, subtract 20x from both sides. Subtract 600 from both sides. And we get 900 equals 130x. Divide both sides by 130. And whatever 900 divided by 130 is, and I'm just going to say it's like 6-ish something. Let me pull up my calculator. 900 divided by 130 is 6.9. So we're going to say it's about 7 weeks. Actually, it's in the 7th week, we'll say. 6.9 weeks isn't quite enough time. It's in the 7th week. In the 7th week, we can afford the console. And that answers the question, when can you afford the console? Okay, that was some fast problems. I know it might actually be kind of too fast for us. So if that's the case, I apologize. However, it's also all stuff we've seen before. Nothing here was new. This might have felt kind of new. It's not really. Kill fractions when you can. Take care of your negatives. Love each other.